Hello, welcome to another episode of penphysics. Today I will do one of my favorite subjects, which is electric and magnetic fields. And for that I will use a strange pen. This is called the Lamy. It's actually the Lamy Joy. This is the model of this pen. And it has a flat nib, as you can see. This is called a stab nib. And it's often used for calligraphy. And I thought physics is art, so why not use such kind of a pen? And I even have, unfortunately I don't have a converter here. I use a standard cartridge which has like a purple ink. That's okay. So let me go to this question. This is from May 2003. Motion of a charged particle inside the magnetic field and an electric field. So let's start with an electric field. Two parallel plates in vacuum. One is positive with respect to the other, so it's higher potential, plus, minus. This is the path of a positive charge. Passes into the region between the plates. Initially the particle is traveling parallel to the plates. And the question is, on the diagram, draw lines to represent the electric field between the plates. So this is a very standard question that they ask for 3 marks. So you know what to do here whenever you have to draw fields. Let me actually do it on a separate piece of paper. So this is question A1. Let me draw the field again on paper. The positive plate, the negative plate, and you know inside there is a constant electric field. How do you draw constant fields in general? Parallel lines, equal distance or equidistance, equal distance from each other. And if you want, you can draw the edge effects, will kind of bulge out. Correct direction is what? From positive to negative. So you have to give this, and this is good for 3 marks. That was kind of easy. We did this in a few seconds. The next question is, show the path of the particle as it passes between and beyond the plates. Okay, so let's say this is the particle entering, it's positive. The particle entering the plates, what is the force inside? The force is given by E times Q, and it's constant because the electric field is constant. So what kind of motion is this? It's projectile. This particle is launched inside a constant force, a constant field. So it will curve down with a parabola. That's a parabolic path. It will be attracted, because it's positive, it will be attracted towards the negative plate or repelled from the positive plate. But if it goes out of the plates, then there is no force. So whatever velocity it has at that point, it will keep it, and you can draw a straight line after that. Okay, and you can see how this stab nib works. It does thin lines if you draw it like this, and does thicker lines if you draw it like this. So that's like for a calligraphy style of writing. Anyway, that was A2. Continuing with the electric field, an electron is accelerated from rest in vacuum through a potential difference of 750 volt. B1, determine the change in electric potential energy of the electron. So this is B1. So let me call this delta U for the change in potential energy. You can call it E of P for potential. It doesn't really matter. This is joules, it's energy. So what is this? This is the charge times the difference in potential in volts. So that's in Coulomb, that's in volt, this is in Joule. So since this is an electron, this is 1.6 times 10 to the minus 19 times 750, and you can find this answer in joules if you do the calculation, or you can say this is one electron we're talking about, this is 750 volt. So what is this? This is 750 electron volt. Remember, this was the other units of energy that we often use in atomic physics or electricity, smaller unit. And that's a perfectly fine answer. That's okay. So this was good for 2 marks. And don't forget the units when you do the calculations and show your work. And last one for this part of electricity, deduce that the final speed of the electron is this 1.6 10 to the 7 meters per second. Okay, what do you do here? It's conservation of energy. It's as simple as that. This potential energy, this electric potential energy has been converted into kinetic because the electron has picked up speed, and since it starts from rest, this is simply 1/2 mv squared. Now I need the energy in joules because this would be in kilograms. If I use the data booklet, the mass of the electron is in kilograms, and I want to find the velocity or the speed in meters per second. So I work with SI units. And this is why I will have to convert the electron volts to joules. So I cannot avoid this. 1.6 times 10 to the minus 19. In coulombs, 750 was the volt. So now this is joule, and this is 1/2 mass of the electron, 9.11 times 10 to the minus 31 V squared. So what is V squared? I like to show all my work contrary to what many of my students do, and they lose marks for that. And you can of course use the GTC and do all the calculations there and show the final answer, but I like to think of what happens to the powers of 10. So I like to count my powers of 10 and have 10 to the minus 31, which becomes 10 to the plus 31 on top, minus 19, so this will give me 10 to the 11, and I work with the rest of the numbers with a simple calculator. But you don't have to do this, you can just use the GTC directly. So this is 263.4 times 10 to the 12, and the final answer is, if I take the square root of that, so V is equal to what? In 2 significant digits, because this is 2, that's the least number of significant digits I have in my calculations, 1.675. So I do get this, which is the answer that I'm supposed to find, if my calculations are correct, which they are. So this completes parts A and B. And the next parts of the question refer to magnetism. So now we have to go and look at magnetic fields.